Welcome to Visual Studio Live. Thank you so much for being here today, yesterday, earlier, and hopefully you'll come back tomorrow. Just a few housekeeping notes before I get on to our wonderful presenters. First of all, you may find that there's this nice little, beautiful, multicolored piece of paper in front of you. A lot of you have Visual Studio subscriptions. Yay! And you install Visual Studio, log in, and that's what you do. Just don't forget, there are tons of wonderful other things provided in that Visual Studio subscription, including the ability to download SQL Server Developer Edition and get all those great enterprise features right on your machines. So check that out, the C# Dev Kit, those free Azure credits, all the good stuff. We want to thank our sponsor, Microsoft, for letting us be in this wonderful facility. Isn't this a great place? Get to come up here. And then last night, did you get a chance to talk to those product team members? Got your free hats? Well, thanks to the Visual Studio team for that. We're really happy that they're here. And don't forget that tomorrow night after the last session, the Visual Studio and .NET teams will be over here. They want to hear the things you love about Visual Studio and .NET, as well as the things that we can do better. So let us know. We want to make it the product that you want to use and recommend for your friends and family. Yes, got to get those kids started early, right? So without further delay, I want to remind, and I have to say it, sorry. Do those session evals. We really do read them. We do care. It helps us plan the show. We want to make it a show that you want to attend. But now that we've hit that magic number, look, 987, building applications with modern SQL using AI and Microsoft Fabric. That's a lot of words, but the best part is you got some amazing presenters here today to talk to you about it. And we're going to start by welcoming up Asad Khan, who is the Vice President of SQL at Microsoft. Asad, the floor is yours. Give him a round of applause, please.
Hi, everyone, and thank you for coming. We are really, really excited to have you all. And we are really excited to talk about the innovations that we are bringing in SQL and how those innovations help you as developers to build AI application. And as Brian said, my name is Asad Khan. I am the Vice President and GM for SQL. In this role, I run the engineering and the product management for the SQL offerings that we have in on-prem and in the cloud. And later, I will be joined by Bob Ward, who needs no introduction, has been the architect for SQL and a member of the SQL community. And Muazma, she runs and leads our AI investments for SQL. SQL has a very interesting history over 3 decades. And the interesting thing you will notice is that many of the data products, not only the databases, but even in the big data space, who started on-prem, had a struggle to transition into the cloud. But you will be pleased to know that SQL in Azure is by far the largest PaaS service that we have. We run over 13 million databases just in SQL DB. All these databases are versionless. We upgrade them every month with no developer worrying about the backward compatibility. We run over 45 trillion queries every month. All of those queries go through our intelligent query processing, where we get the opportunity to optimize those for you automatically. Recently, it is not on the slide, but recently when we launched Arc, which allows you to connect your on-prem databases to the cloud, it is like you have now SQL running on the edge. We have more than 6.6 million cores already connected through Azure. And that gives the customers the ability to continue using the SQL the way they are doing, but also take advantage of Azure. And one of the reasons that SQL has been so successful is the strong community behind SQL. Strong community of developers, DBAs, IT professionals, the partners we have that have built a rich ecosystems of tools and services, the system integrators, the ISVs, who have more than 6,000 applications certified on SQL. So first of all, I want to thank all of you for being such a strong partner on this long journey that we have on SQL. Thank you very much. As we think about the next phase and the investments, this is the structure that we use internally also when we think about the investments. Think of these are our swim lanes. We want to make sure that we are investing in each one of these categories. I will talk about the first one before I bring onto stage Muazma, who will talk about the AI, and then Bob. The first one is about the investments in the database itself. This is super, super critical. We want to make sure that you as developers don't have to think about the security, the reliability, the scalability that your database offers. And this is where SQL has been an industry differentiator from the very early days. And the good thing is that even as we brought those database technologies to the cloud, we did not break any backward compatibility. And that is the reason you can switch between on-prem and cloud so easily or run in a hybrid environment. There is a lot that we can talk in this category, but I will just talk about 3 key things which I think are the most differentiated and helps SQL to be a leader. The first is the database layer itself. And this was published in the research paper under the name Socrates. We call it hyperscale. This is where we have separated the storage layer, the compute layer. We use the RPPX. This is what gives your queries 2 milliseconds of query time. This gives you the never to worry about the scale because you can go over 100 terabytes of a single database. The other thing that it provides is instantaneous scale up and scale down. Or you can add read replicas because the storage doesn't have to change at all. We recently published through a partner, published the price perf, which is the key benchmark for any database and how it gives you 68% advantage over our competitors. And if you look at many of the case studies which are just published on the hyperscale, the one thing you notice is the variety of the use cases. Whether it is Schneider doing the IoT scenario and having really, really large database, and their database continue to grow as more data from the IoT is landing, or whether you look at the Hi-Rez, which is a gaming company, and for them, the concurrent users and the spikes are super, super important, and they don't have to worry about the scale up and scale down of the databases. Or whether you are looking at the CreditNet, where they run more than 500 million transactions and have a microservice architecture. Or when you go to the DHL website today and track your packages, all of that is flowing through hyperscale. And they have the advantage because they keep adding more read replicas as the workload increases across the world. So that is the advantage of the hyperscale. Think of it, it is not a document-only store. It is not a JSON-only store. It is not a specific store for anything, but it is a truly rich database offering, which has the rich query capabilities along with the rich modeling capabilities for your data. The second thing I want to talk about briefly is the elastic pools. SQL is the only database in the industry that offers this. And I will explain this one through a simple example. When we started working with Dynamics and CRM, which is a Microsoft-owned product, they had a problem, which is like, how do you go and build a cloud-based offering while serving all their customers? And because each customer has their own database. Now imagine that if you have millions of customers, you have to have millions of databases to support. And today they have over 3 million SQL databases. Now, even if you make every database serverless, you have to worry about what will be the total cost to your company. That is where the elastic pools are super, super powerful. You can buy the capacity once, and then you can pack up to 500 databases. And later we will talk about what we are doing to even remove that constraint through the fleet management. So this is, again, a truly differentiated thing especially for companies that are building SaaS application, because you can continue to have the isolation of a database, the security of a single database, but not worry about how they will scale up, scale down, or what will be the total cost to your company. The third thing which I want to briefly talk about is why so many applications are built on SQL successfully. And it is about the full ecosystem. Whether you are looking at the drivers, where we support all languages, whether it is about the tools, integration into VS Code, Visual Studio, the Copilot experiences that we just delivered, as well as the database watcher that makes sure that you can monitor each and every aspect and then have triggers to ensure that you can take timely actions. Or whether it is the security. Security has been a differentiator from the SQL from day one, And we made sure that we have that leading position in the cloud as well. So whether you are talking about encryption or always encrypted, or whether bringing your own keys and making sure that nobody can access your data, not even Microsoft themselves, or whether it is about the private endpoints and other security offerings that we have through whether Entra ID only and other security features. The next is the built-in capabilities for the database itself. And as I mentioned, SQL is super rich when it comes to the database offering. It offers the JSON type. It now is bringing the vector type in there. It has the ability to call REST endpoints and so on. The other thing is that as a modern developer, you also care about not only SQL, but how it integrates with the rest of the ecosystem, whether you are on-prem or you are on Azure. And that is where SQL differentiates in terms of the integration. And you will hear more about that in today's session as well. So as I mentioned, when it comes to the databases, when it comes to the core capabilities that we offer, we can cover a lot. But the three things which I wanted to talk about: hyperscale, how it is differentiated, elastic pools, and the rich ecosystem of what it offers to the developers. Next, I want to call Muazma on the stage and talk about the AI capabilities and where we are investing. Thank you.
Thanks, Asad. How many of you are developers? You're in the right room then. My name is Muazma, and as Asad mentioned, I lead the development and AI strategy for SQL. And today I'm going to show you a lot of demos in this space about building AI applications using SQL, Azure SQL and SQL Server. In terms of my focus is these two pillars. So Asad already mentioned and shared a lot of you in terms of the ecosystem that we have today with the developer space. In the AI space, as this is brand new, a lot of us are still learning and adding features. So your feedback is very, very welcome. So please share that with us towards the end of the session and talk to us as well if you have any questions. So starting with what is the AI developer platform? So when we are looking at features from a SQL perspective, SQL is not on an island, right? It is part of an ecosystem where you're building these applications. So on the bottom of this chart, as you can see, is our host, right? So it's your hardware layer. It can be in a cloud provider for a cloud provider like Azure. It can be in your data centers. It's the GPUs, the NPUs, whatever you have. And it's very important for us to understand that layer because of these models that have higher requirements than the ones that used to be used in the past. The next is the models itself. So as we say in the team, that there is a models war going on. Every single day or every single week, there is a new model out there which is beating the other ones. And we are looking very closely at these models, both from Azure OpenAI, as well as open source, and how you can use that for your AI workloads. Now, once you have a model, you need to host it somewhere to inference something from it, maybe a chat completion, maybe for embeddings, any use case that you have. And there you have different options again. You can use Onyx Runtime, you can use it in a container, you can use Olama, you can use NVIDIA, all of these inferencing engines that are out there, or maybe a hardware-provided inferencing engine. Now, my team, and we are SQL team, so that's data. Data is the fuel that runs AI. Garbage in is garbage out. So what we are focusing on, a lot of features that provide built-in capabilities for this AI ecosystem. That includes the vector store, vector functions, calling REST APIs to call these models for you, and then also thinking about how you can build search indexes and integrations with Azure ecosystem, including Azure AI Search, Azure AI Studio, and many more. Last but not least, as all of your developers, so when you're writing applications, you're using these frameworks. So we need to be integrated with these frameworks, including EF Core, LangChain, Semantic Kernel, all of that. So you will see today in the demos some of these integrations and also some examples of how you can actually build AI-ready applications using SQL. Now, why SQL? This is a question that comes up, like, why should I use SQL for this? SQL is known for last many decades for these things, for the security, for the reliability, for storing your data. And as I said, data is the fuel that runs on AI. We think bringing these things together, SQL provides you a mission-critical database for the era of AI. And then we are very closely looking at the responsible AI principles, so definitely check them out at the AKMS link on the top. Now, building AI applications. So the examples that I'm going to walk you through today fall into these two categories. We are going to talk about vector and hybrid search, and a pattern that is very common these days, which is RAG, Retrieval Augmented Generation. What is it in terms of that? Before we go into details, let's ground ourselves in some technical terms. The first thing I want to talk about is what is vectors. How many of you know what are vectors? A lot of you, awesome. So let's think of a text as dog. It's somewhere in your table written in as one of those columns. It can be a text, you can have a picture of a dog, or you can have an audio clip that says the word dog. Now, all these three things mean three different things for these models. And not one model can understand the same three things in the same way. So it's a very important thing that you understand how these large models or small models work to work with the data that you have. The data can be text, the data can be an audio file, data can be a picture. Now, in terms of understanding for these models, a dog has many features. In this case, it could be the height, the weight, the color, the fur, how it looks, and all of that. And that is what it describes. The model describes the dog and understands what the dog is in terms of numbers. What those numbers are, it's what is called embeddings. So if you pass the term dog to one of these embedding models, it will return you a vector. A vector is nothing but an array of numbers, and this is what it will look like. Now, two embedding models will not have the same numbers for the same text because they understand the same text differently. So it's very important, again, to understand which model to use for what use cases and how do you actually store those embeddings and retrieve those for your search scenarios. So you're going to see some demos today about that using SQL vector capabilities for vector and hybrid search. Hope it clarifies some of the concepts for you. Now, a little bit more in terms of the RAG pattern. So what you have is, as I mentioned, vectors and embeddings. So let's say you are a call center and you have all the call text data stored in your SQL database. Now that text data can be stored in the database as vectors, right? The way to do it is you have to send it to a language model, get the numbers back, which is the embedding, and then store it back in your database. That's the top part. Now, once that data is stored, you have an input prompt, which is your text that you want to search on. For example, you want to find the calls that have a particular problem that customers are facing. Now, in order for me to search that problem with everything else that is stored in that, I need to find a similarity or a distance between the text that's the input and what is stored in my database. And that's what we call a vector search. And for that capabilities, you have vector search functions which use distance measurements like cosine, dot product, equilibrium, and some more. Now, what is this RAG thing? How many of you know about it? Okay, a few of you. So RAG is you're taking, so if you send just a plain input to a large model or a small model, you get a response. That's what today ChatGPT does, a lot of these models does. Now, what you want to provide to these models is some more context on your data so that the answers you get back are more grounded in your data set. So that is the augmentation part. So you now provide the input data as additional information to the model so that the result that you get back is more accurate. So this is what the pattern of RAG is. And again, we'll see some demos today so you get the understanding of how you can do it using the data stored in SQL. And finally, your goal as a customer or as a user is to increase the accuracy of the search results because you care about what you're searching for, how fast you're getting the result, and how accurate that is. And that is the whole pattern of what we see AI-ready applications, especially with vector search and RAG patterns. Now, in this demo, in this session today, in this keynote, we are going to talk about 2 out of these 3, but these are the patterns that we see with the customers' discussions. The first one is using SQL as a source to index that in Azure AI Search. AI Search, previously known as Azure Cognitive Services, has been known for years to index your data very well and to get the semantic meaning out very fast. Now, with the capability called integrated vectorization, what you can do is you can index your SQL text data very effectively in AI search and run queries on it. So basically, it's a chat with your data scenario. And I'm going to show you a very good demo about that. The last scenario here, and I'll come to the middle one in a second, is the RAG pattern. And this is where we believe that SQL has already got a great set of capabilities in terms of searching. It already has the full text search. And then adding vector search to it, you can build a RAG pattern search, hybrid search, vector search within your SQL database. Again, you'll see a demo of that today. Now, the middle one is where we see companies going in the future, especially for the ones where you have your own data sets, where you want to fine-tune a model with your own databases, with your own data that is stored in your databases, and use that to actually use natural language to generate SQL. And we also see many applications, and Bob is going to show you later, the NL to SQL type applications that we have built using that pattern. So let's focus on the first and the third one and see some demos. The first scenario is chat with your SQL data. In this scenario, I'm going to use 3 services: Azure SQL Database, Azure AI Search, and Azure AI Studio. You can use something else at the end to deploy that chat service in your app as well. But I'm going to show you a chat application in Azure AI Studio. So how will you do that? So just walk you through the steps, and then we'll see the demo. Today, AI Search stores can basically, as a data source, take any of the SQL, even on-prem SQL server can be connected to the Azure AI Search. You can use SQL MI, you can use SQL DB, any of the flavors that you have can be connected. The first thing is you need to go into Azure AI Search and create an index on your data. Now, very important question, this is a question I get from customers a lot, is how often should I update my index? So it totally depends on the total cost of ownership that you want as compared to the accuracy of the result. So for example, if you're okay to be not 100% accurate, or because it's never going to be 100% accurate search anyways, it's probabilistic, can never say that word. You have to decide that are you okay for a few hours to not update, let's say, your index, as compared to as soon as the data gets updated, you use change tracking and update that. So in Azure AI Search, it has a capability that you can check mark that as soon as my data gets updated, please update my index. Or you can set up a schedule like every 2 hours, 5 hours, 6 hours, whatever that is update my index based on those changes. Now, once you're done with that, you can build these things called scales. So this is a capability as part of the feature set in AI Search, which is called integrated vectorization. And part of those scales is you define an embedding field where you can basically take your text data, convert it into embedding, and then Azure OpenAI service is called to actually convert that text data into embeddings. Now, finally, of course, once this is all stored, you want to prompt it, you want to test it out. So you can test it out using Azure AI Studio just through the APIs that it provides, or deploy it in your web app and run from there. And that's the end-to-end result that you want to see. Now, how to do that in this case? In this example, I have retail data. It has product names, descriptions, URL. And here is what I stored. The first step you have to do is actually to connect to your data store. In this case, a SQL database hyperscale. And you can call it whatever is the name of your database or some new name. Once you're done with that, the second thing you need to do is to create an index and an indexer. So index is the most important step. And this is what it maps for the data that I have. Again, very simple example here, but you can make it as complex, combine multiple tables. You can combine multiple data sources as well if you want to. Here, the important thing to note here is that new field embedding, which is the string collection one, it's not coming from the database. Everything else is coming from the database. But what I'm doing on that embedding field is basically creating the embedding on the product description column and product name column together and storing it as the numbers that I just shared the concept with you in the previous slides in that particular index. So that's my second step. The third step, which is not mentioned here, is the indexer, which means how often do you want this index to be updated? So it's a simple setup. It takes like less than 4 or 5 minutes. Depending on the size of the data, the index will take some time. For me, it took like, for 30,000 record, it took like 3 minutes or less than 3 minutes to create that index. Now, let's go to searching. So here I'm using Azure AI Studio, and they have a chat playground. Again, you can use the API or you can deploy it for you. Here I'm going to go in. As you can see from the source, there's an option to choose your data. And in that data, I've selected the AI search index product data that I created in the previous step. Again, it takes like less than 5 seconds or so to set that up. And I'm going to ask about what products to buy for kids' first birthday. And now this data is actually using the RAG pattern stored in my database, going into and not only providing me the products that I think are relevant to that search, but also providing me the citations. And in this case, when I click on the citations, I can see the actual product name, URL, and all of those details as well. Now, just switching gears here, just to show you some more capabilities, I am asking about what are the best products for living room decoration. So again, it will go in, search for the right products for that, provide me the names, product URLs, all the columns that are part of the index that I've created, and provide me those answers with those citations. Now I wanted to take it to the next level. So this is, you can keep it testing, you can further modify it, go back to your index if you see something is not accurate, and can stay in this chat playground for some time. By the end of it, when you are ready, there is an option to actually to export this out and actually deploy it to your web app as well. Now I wanted to see, can we do some multimodal stuff here or not? So as you all know, that OpenAI came up with the new model, which is GPT-4o, and there's a mini version of that. And in this case, now I'm using that to actually add some pictures to my search as well and see how well it does. So now that I'm into the living room space, I wanted to see what decor can go with this product image. Now this product image can easily come from my database. And this is the image that you briefly saw there. It's a gray sofa. And you can see that now it will start providing me relevant information about that can be then grounded in the data set that's stored in your database. So again, this is to provide you some ideas of how you can actually use these models to actually ground that in your data sets and then get more accurate results for what you're looking for. Now, just for fun, I was also thinking, what if I'm a marketing team? And instead of like asking for like a user scenario, a customer scenario, I'm a business owner and I want to actually create ads and I'm selling this in France. Because this new model, the 4o mini that you can see on the left I'm using, it has multimodal capabilities, not just for text and image, it also have multiple languages. So I'm going to ask, give me a French ad for the sofa product image provided. And there you have it. So it will create the entire ad for me for that. So that's the power of chatting with your data, getting like chat applications up and running without learning a lot about end-to-end how each of these models work. Most of these standards work really well. Again, if you have any very specific scenarios, specific use cases, please talk to us for more questions or answers, questions or scenarios that you have. So this was my first scenario in terms of chatting with your data with Azure SQL database and using AI search and AI Studio for the chat playground. Now, the second scenario is a fun one. So we have Davide in our team who's an Italian. We were just brainstorming, and he's always thinking about food. So he came up with something that he really likes to eat, which is focaccia bread. And it's really hard for me to pronounce it every single time. And he said it will be really hard to find the best focaccia bread in a town that we are visiting. So in this case, let's say we are in London, and we are looking for a very specific bread, focaccia bread, in that. Now, this is what SQL is known for years. SQL is known for quality search, inequality search, geospatial, all of these capabilities that are there. For example, you want to search that in London. You want to make sure that it's within the 5-kilometer radius of wherever you're located. That's a geospatial search. Now, SQL supports regex. So you can do a regular expression search on categories. You want to make sure that the place that you're going to has enough reviews and also has good reviews. So it's greater than 4-star. Now, this is what we have been supporting for many, many years, for decades. Now, why I'm talking about AI is this focaccia bread. Now, this focaccia bread information is actually stored or hidden somewhere in this review column as a review from a customer which says, this restaurant or this place has the best bread. And that's where we think using similarity search, using Gen AI capabilities, the vector search capabilities that I just talked about, would be really, really useful. And we strongly believe that SQL is the ultimate engine for hybrid search scenarios, because you can filter that. You can use all of these other predicates plus the generative AI search or similarity search on top of that to make sure that your results are the most accurate ones that you're looking for. Let's see this in action. So this is the database. There are two tables, business and reviews, about 200,000 businesses and 8 million reviews stored in this. Now, starting with the search, we're looking for in the city, London, with stars greater than or equal to 4, so at least 4 stars plus. This is what the results comes out, but you can see there are Italian places, Thai places, other places are also coming because they're all in London and having more than 4 stars. Now, we are going to, like you can see here that we have the geolocation. So next search we're going to add on this is the geolocation capabilities, where we are saying that it should be within the 5-kilometer radius. After adding that, the results are making sense, but it's still not there because it's still finding all of the restaurants there. The one that we are looking for, and according to Davide, there should be an Italian pizza place. So we're going to use regular expression search in addition to that, where we are looking for place, which is Italian and pizza place. Now, then you can add it as many predicates as you want. You start to see a lot of great results, but still not there. Now, how can we actually make sure that this result of looking for focaccia bread is the most accurate one? In this case, what we're going to do is now do the vector search capabilities. So for that, what we're going to do is this is the review that we are looking for. So remember that number 307, 305, and as you can see, it says that they have the best focaccia bread, and the person who wrote the review, they say that they love it. Now, in order to do that, we have a capability called SP invoke REST endpoint, which from the database data, you can call a model, in this case, OpenAI model, using REST. We are sending input text, and as you can see, a place where to get some good thick focaccia bread. Note that the spelling of focaccia is different than the one that is in the review. It's with K and the other one is with C. That's where the capability of AI is really, really amazing. After we do that, we're using cosine distance, so finding the closest review to the input text and the one that is stored in the database. Now we're combining all of that together in this query, what you saw in the previous slides, and then order by date. So you're finding the closest distance search results to the ones that are stored in your database. It has the city search, it has a geolocation, it has these stars. Let's run it and see if we get the review that we were looking for and the place, that business that we were looking for. And let's see the result. And there you have it. 307, 305 is the closest to the search that we were looking for the best focaccia bread. Now, as a developer, you're not looking for all the answers, like you're not looking for all the relevant one. In your app, you want to share the top restaurant that is the most relevant one. So there you need to aggregate this data. In this case, we're using JSON data type and JSON aggregate functions to actually combine that result in the app and then aggregate the top relevant reviews that are relevant to it. So in this case, you saw that that restaurant is repeated multiple times based on the reviews for the focaccia bread, but there are other restaurants also. And they all have different similarity to the input text. So here, with a very simple T-SQL code, we can actually add this clause. You can average the star similarity and all of that. The important thing to note here is using the new JSON array aggregates. And then we are seeing the review IDs for the JSON object. In this case, now when you run across all the businesses, you can get one aggregated result. And this is what you can then put in front of your web app or front end. So as an input user or customer, you come in, you're looking for the best focaccia bread or your best thing that you want to eat, you can go in there and do that. So this kind of concludes the hybrid search and vector search scenarios. Now customers are also pushing us further. So what if your vector search is good, but it's not as good enough for the rest of your full text search that is already in SQL DB? So there's a concept called re-ranking, where you can actually compare two different types of searches and rank them and see which one is more accurate to your input. So in this case, you can use the full text over there, and this is the vector distance one that we just showed you. Between the two, what you can do is a very simple mathematical calculation, what is called RRF. It's called reciprocal rank fusion, where you can compare the two results and decide on the runtime in your app which one of the results you want to use, if they're close enough or if one is better than the other. And that's what we again say with hybrid search and re-ranking, you have the best solution to search for the data that you're really looking for in Azure SQL database. We're not stopping just there. As you're all developers, we know that you are looking at building applications using your favorite language and frameworks. So we have integrations with Entity Framework Core. It's already out there. We have integration with Semantic Kernel. And then we also have integration with LangChain. So if you are building applications using any of these frameworks, definitely check that out. And if there's any feedback, please reach out to us. With that, I will call Bob to actually show you our Copilot services, which is an AI service that we host for you, and a lot of other demos. Over to you, Bob.
Oh, thanks, Muazma. Wow. Oh my gosh. Is your brain kind of blown by that last 20 minutes? I know I am. You know, I loved how Muazma did kind of that low-code approach, right? A little bit with Azure AI Search, OpenAI, and so forth, and then showed you the investments in the SQL engine itself to do that RAG pattern. Hope you noticed in there regex, JSON types, spatial. We want you to have confidence that you're relying, a lot of you in this audience, on SQL as a technology, and we're right there at the forefront of making sure you can build AI applications, and we're just getting started. So yeah, Muazma leads our team in this space, so it was really great, a lot of information she showed you. In case you're wondering, there was a lot of demos that she showed and all this decks here. I'm sure you guys want this. So at the end of this presentation, I've got a location where we've uploaded this entire thing for you. You can take a look at this even after this session today. So there's no question that copilots can be a technology considered as an AI application. I don't know about you, but I've seen some things on social media called copilot burnout, that there's so many copilots out there, you can't keep up with them. There's this term Microsoft has called the age of copilots. I showed this to my sons. They said it sounds like a Lord of the Rings movie, the age of something, right? But what it is actually is a set of really impressive AI assistance technologies that are across Microsoft products. In fact, I've got a tip for you. Don't worry about finding all the copilots. Just use some Microsoft technology like 365, for example, and then just start using what shows up there already. I can tell you right now, as a Microsoft 365 Copilot user myself, I'm saving 2 hours a week in my job just using that kind of technology. Now, we don't want to be left out of that space. So in SQL, we want to invest there as well. We'll talk briefly a little bit about GitHub Copilot at the end of this type of section of the presentation. And we got more investments coming there. I know in this event itself, I know Brian Randall would love me to say this, that GitHub Copilot is a massive investment for Microsoft, but we want to be part of that story as well. But what we've done over the last 6 to 8 months is invest in a Copilot experience inside Azure called Copilot in Azure. And there's a SQL experience inside that. We kind of like to talk a little bit about and show that to you. So this is part of the story. Back last summer or so, the team working this reached out to me and said, Bob, you've been around for a while, 30 plus years at Microsoft. You've been working on SQL for a long time. We want to build a Copilot for SQL. I'm like, really? So you want to build something that just generates SQL queries? Yeah, we want to do that. We want to do natural language to SQL. That's part of our story. But what we want to do is something that is industry differentiating. We want to take Azure database context, like somebody's in the portal, and we want to use the deep, rich telemetry that has been this engine you know and love for like 20 years, right? We want to take DMVs and all the things that are inside that the SQL engine produces and use a RAG pattern. We want to go feed some of the results of those things to a model and see if it can generate a pretty cool response based on maybe imprecise questions. You know, it's funny, being at Microsoft for so long, I used to be in support. I used to have this phrase called, I love errors. I don't know if you've heard that term before. Why do I love errors when I troubleshoot our problems? Because it's a known place in the code. This error is this problem. But performance is not like that. So the team asked me, where should we start? And I said, we should start with performance. It's one of the most difficult problems with a database, including SQL, for developers and administrators, no matter how you spin it. Why? Because the problems are vague. So let's show some examples. Now, first of all, when I got a hold of this Copilot in Azure, the first thing I want to do is ask it, like, what can you do? Like, I don't even know what's possible. Now, I'm in the context of a hyperscale database. The Copilot for Azure framework has a way to feed in to our Copilot services, knowing I'm in a database context. So I'm like, hey, what can you help me with? And it has very specific things. It says, I know you're in a database. I can help you with certain types of things. Notice on here, one of the things I can help you with is performance optimization and troubleshooting. So I'm like, I was telling the team, this is pretty cool. And I'm like, what I think you should do is build, the very first scenario you should build out of this thing is I'll teach you how I troubleshoot SQL performance problems and what I see them come to, like customers feed me, and we'll see if this thing can do it. They worked on it for a while. It's like, we think we have something for you. I'm like, fine, let's test it out. And they're like, well, how do we test it out? And I said, well, we should ask it a question like this, or a statement, like something really precise. My database is slow. Because that's what everybody says. It's slow. I don't know what it is. So can you figure out slow? So what it's going to do in this case, they built a scenario for this based on what I gave them. And they said, look, yeah, it's slow because of what we found in our telemetry. There is a high CPU problem going on in this situation. In fact, over the last 14 minutes, it's like over 80%. Something is probably causing the CPU issue. So I'm like, cool, I'm pretty good with this so far. What do you normally do is what query is causing this? So you know what? It identified the query. It said, hey, here's a hash and an actual query statement that we think is causing the issue. Well, it's saying like, here, I've got some ideas for you to go investigate it. Notice down below what it says. It says some prompts for me to potentially go after the problem. It says, would you like to go optimize this and see what's going on? I'm like, sure, hit the button, comes up. You know what? It's missing an index. I realize that's a simple problem to many, but do you know how many people go down the wrong path of performance troubleshooting? They don't know what's causing the issue. They don't know what's going on. And they go down the path of solving something that's not the problem at all. They got to unwind themselves and figure out the issue. Now a Copilot can look at telemetry that you have access to. And by the way, this can only run things that you have permissions to do. And it's just using like SQL queries to feed a model with a RAG pattern to give you answers. So I told the team, I'm impressed. That's great. I think people are going to love that. So they said, well, what's next? And I said, well, when you have a performance problem with SQL, CPU is one of those. Another scenario, though, is maybe like a waiting problem. Like I've built this application and something is waiting. So I'm like, you need to tackle that too, but I got to ask it the same question. They're like, huh? I'm like, yeah, it's the same generic problem slow thing, but a different variation of it. So they showed me this example. Yeah, it went in and said, you know what? There is hardly any CPU going on in this scenario. So I'm like, okay, if there's no CPU going on, could it be a blocking problem? Well, look what it found. It says, you know, it turns out there's a blocking issue here. And here's the session ID. Here are the queries it's running. And here's the blocking chain. Do you know how many people struggle to figure out that problem right there? It takes some hours or a call to support. And within minutes or even seconds, this Copilot is giving me telemetry to go figure out that problem. And this is great. Artie's giving me a head start on this. But I'm wondering myself, as somebody who owns this database, is there a trend with this problem? Now, you heard Asad mention earlier a concept called Database Watcher. This is a new cloud service that is, quite frankly, free to use. You can use a free Kusto cluster with it. And you point it to your targets, which in this case is an Azure database. So I started recording the history of this as I'm troubleshooting these problems. And you know what? Look at this. I can see a specific blocking chain, just like I showed you in Copilot, in a more visual way. You may have scripts you use to do this and other tools to see this. And you're like, Bob, I can do this today. I can run a tool. I can run a script. I can see a blocking chain, who's running what. I can even go back and prove over time that an open transaction caused this issue. So now I know how to solve this issue. But here's what you probably can't do. What about the history of blocking? So Watcher can maintain historical information in a separate store. So I'm like, okay, this is pretty cool. I wonder if there's a trend here. So I'm going to go back and say, show me the history of activity. I'll click there, and I'll change my time frame to something like 4 hours. Because what I want to do is not solve one problem, but a trend of a problem. So I'm like, oh, look at that. There is a trend. Like a blocking problem occurs for a while, and then somebody maybe kills the session or something to get rid of the blocking problem, but it comes right back. So solving one issue on demand is not going to solve the systemic problem. I'm getting the same blocking pattern I showed you live with something that happened 4 hours ago. That is industry differentiating, and that's Database Watcher. So I'm using a combination of my Copilot technologies, my Watcher technologies, to solve problems that could take hours or days now in a matter of minutes, and even look at trends historically. Now, I mentioned earlier, though, we do want to help you write SQL queries. So we have a new experience called the Natural Language to SQL experience. And as Muazma kind of hinted to the fact, we're starting it out by using a RAG pattern with a model we've tuned to know how to generate SQL queries. Now, here's what's interesting how we're doing this. We're going to start by using the query editor to be that experience. I'll just tell you what, we want to put this everywhere SQL exists, so get ready. This is going to show up at other form factors. But today, we're going to use the query editor in the portal. And here's what we want to do. We want to be able to take your schema, your table definitions, your key definitions, your relations between tables, and feed that to the model and say, hey, here's a natural language prompt like the hierarchy of product categories. Anybody ever written a hierarchy query in SQL? It's not easy to do, right? So what do you typically do with that? Well, I'm going to feed the table definitions to the model. I'm going to give it the prompt, and it's going to come back. And this is live. I didn't fast forward this thing. It's going to give me a recursive CTE query. I don't know how many of you out there just write these things in their sleep. I know Davide does this in his sleep or something. I don't. So this is really great to either A, get me started, or show me an exact query I can go put in my application that allows me to do a recursive CTE, do hierarchy traverses, put this in my app, and run this. So I can take this query, paste it anywhere, use what I want, and do what I like to do. And there's so many other examples of how this technology is helping people with Copilot experiences. I had an original slide up there, ak.ms SQL Copilot. This experience is in preview today. It is definitely our intention to bring Copilot experiences wherever SQL exists. We're starting today in the context of Azure Database and natural language, but we want to go further than that and even put that in an integrated GitHub Copilot type experience. So that's a little bit look at Copilots as an application to help you as a developer with databases. So when you start thinking of Copilot technologies, I was one night at home, talking to my wife about something on my laptop. She goes, what are you doing? I'm like, well, I'm going to have fun with this GitHub Copilot thing. And she's like, what are you talking about? Why are you spending time doing this? I'm like, well, it's just weird. I just like to do things like this. So I'm really not making this up. I brought up GitHub Copilot. I put on my Camtasia recorder, and I recorded this. We'll see if you think it's kind of funny. So I'm like, hey, instead of me going look at an example on the internet, like what's an example to go build an app using C# that connects to an Azure database with multi-factor authentication, with Entra, and runs a query. Instead of looking at, for example, to get started as a template, I'm going to let Copilot do that in Visual Studio Code. And it's like, you know what? I can do that. And I was like, that's not bad. Like in seconds, this is a live recording. I captured this. This is really cool. And then I thought, ooh, there's all these new people called Python developers. So before I accept this, I just thought I'd play with this. I'm like, hey, oops, can you make this Python? Like the same thing I just asked for before. I didn't describe again what I had to do. I just said, turn this into Python. And it said, sure, I can do that. Turns all into Python. Same code, same problem I'm trying to solve. Connect to database, Entra authentication, what? And then I'm like, oh, no, what about all those Java? I don't make the Java people mad. So what about Java? Can you do that? It's like, yeah, I can do that. Now, by this point, I think it's getting pretty pissed. Like, it's like, can you make up your mind on what language you really want out there? But I'm like, this is not bad. So I accepted this. I got done with it. I'm like, can you convert what you accepted now into something else? Now, I've been around a long time, so I should have put COBOL in here. But anyway, I don't think I get COBOL to work. But I'm like, can you do C++? Because I'm kind of an old school person. And again, I've already accepted the code to do this. And I'm like, can you just do that? And sure enough, it did that. I'm sorry. This is the kind of technology in my mind as a developer that helps me get started with examples or helps solve problems I do. In my session tomorrow, I'm going to show you how to take an example and solve some security and scalability problems using Visual Studio Copilot. So that's kind of a fun example of how to use GitHub Copilot. I've shown this several different other events before, and people minds are kind of blown about that. Okay, so we've shown you the developer experience. Asad talked about what we're putting in the product for you. Muazma talked about the complete development AI experience to help you build a Gen AI app with your data. We just showed you Copilots to help you get assistance, whatever you're doing. Let's talk a little bit about the Microsoft Fabric to conclude today. So I don't know how much of you have spent time with the Microsoft Fabric. People have asked me many times, what is it? I usually show this diagram to do it. And I want you to think of it this way. You're in an organization with many different personas across many different departments doing all of those icons right there. Everybody's got a different job to do those things. But then all of a sudden now you start hiring people that blend across those personas a little bit. And so now they need a very integrated way to do those kind of tasks, data science, data warehousing, whatever. And you need a single data store to do it. You need a single place where this data exists. And in some cases, a common format. And that's really what Fabric is all about. It's about bringing in a one lake of data across all these different types of personas to do many different things, governed by Purview, powered by AI. It's a lot, all in a very nice, compact cloud platform. What does it have to do with SQL? Well, we want to be part of that story too. So in public preview, we have this concept called mirroring. You can take a SQL database and you can mirror this into this one lake in Delta format. Now all of a sudden we can be part of all those icons up there. You can start doing and using SQL data in a very seamless way, even with automatic change capture from the SQL database into the actual one lake. So this is what architecture kind of looks like. You set up your Azure SQL database and say, I'd like to mirror this thing. And then we start putting and syncing it into one lake automatically for you in Fabric. And then as changes occur in near real time, we push those changes back into one lake. They're automatically fed in the system and now available to you. So let's see what it kind of looks like a little bit. So this is Bob and his Fabric workspace. I'm going to mirror an existing Azure SQL database. I'm just going to use the AdventureWorks sample to do this. So I'll put in maybe, hey, here's the name of the database. I can put in credentials. It fully supports Microsoft Entra authentication. You can go passwordless with managed identities. I've already kind of set that up here. So I'm going to go to my logical server in the cloud and pick on Azure Database. And I want this to be simple. So in this graphical interface, I can simply say, hey, mirror the whole thing, or I can selectively pick which tables I want. And in this particular case, there's even some warnings about if there's certain data types that we don't support today that might miss the mirrors in case you're not surprised by that. So I kind of time-lapse the experience a little bit. It's pretty quick actually to do this. So I said, hey, let's go mirror the database. It's sitting in Azure. And now you get kind of a little bit of a real-time monitoring, but how many rows get fed in, what time they were done, what happened in your system. That's as simple as it gets to mirror this. Now, in addition, in this example, which is AdventureWorks, like an ordering system, I took a Cosmos DB database and I also mirrored it. And in the Cosmos DB database, I have like customer surveys that are associated with these sales orders. So what I did is I like, hey, bring in both of these together in an endpoint so that I can do what you would normally want to do, join them. So I can now go take this data all in one lake that's related, but in two different data sources, have them both mirrored automatically in. And now I can actually do things together with this data, which might be difficult to do otherwise doing that. So I'm going to run SQL queries, for example, to take this and go join this together. Now, one thing that I'll show you in this experience right here, you should know, as you look at these things like ratings and joining and looking at data, the Fabric team is really investing hard in Copilot technology. So it's not available yet, but I want you to imagine building this query out like we showed you in natural language query about getting Copilot assistance in the query editing experience inside the Fabric itself. Pretty cool stuff. It's available in the warehouse experience today in Fabric, but it's also going to be part of this whole lakehouse experience with our one lake. So I can join them together. That's pretty cool and interesting, but that's not really all that exciting. Like I want to do something that's very Fabric-y. I think I just invented a new term, Fabric-y. So let's do something like this. My colleague Anna Hoffman built this. If the survey data is inside this thing, shouldn't we be able to do something like this? Sorry, let me go back here one. Yeah. Shouldn't we be able to do this? Whoa, it just kind of skipped around on me, didn't it? Let me go back one. Here we go. So Anna's a data science, actually has a degree in data science. So she showed me, she's like, Bob, if there's survey data in your database and you have other data, why can't we build a notebook with Spark and call OpenAI in your example, feed it the surveys and do a RAG pattern to get back suggestions on how to improve our product? I'm like, can we do that? She goes, we can do that. So she helped build this notebook. We're in Spark. We're just talking to OpenAI in this Jupyter notebook. Then what we do is use PySpark to take a query from our data, take a prompt to ask for suggestions. This is the RAG pattern Muazma talked about. Take your query results, take the prompt with it, and let the model come back and give you suggestions of what to do. And so when we run this thing, it comes back and it says like, okay, well, here's your results. This is the query about all the orders you asked for, and you're feeding it the reviews. So you want to get suggestions on what to do. And so Basically, it comes back with the results of the table and then gives this nice little text summary. And this is where the generative part of Gen AI comes in. Like, I don't want just this table back of results. I want you to look at the text and literally say, hey, in a very nice summarized way that I can understand, tell me what to do. And in fact, it actually summarized and looked at it and said, look, you got a website problem, basically. As most of the reviews that come out, your ordering system is really what's causing you a lot of issues. So go do that. So a pretty cool example of doing that kind of RAG pattern inside the Fabric. Now, finally, I don't know about you guys, I am not a Power BI expert. I'm no guy in the cube. But it'd be pretty cool if I could use a Copilot to help me in Fabric. So I can go in and build what's called a semantic model based on the tables that I mirrored from both Cosmos and SQL. I can pick all those tables. And then I can go to the Power BI experience in Fabric. And I can say, hey, you know, you've got the data. You've got the model of the data. It's all related together. Can you build a Power BI report? So there's a new Copilot experience in there. And we're going to use that and say, hey, Copilot, help us do something. So we're going to type in natural language, create this customer behavior report in a natural, that's kind of analysis. It comes in and it kicks off the report. This story gets even better. There's something called a narrative visual, where you can take the narrative visual from those icons there, drag it onto your report, and it'll summarize that natural language experience in your report itself and refresh as the report gets refreshed. So pretty cool technologies to show you. I showed you Copilot experiences to help you with development, troubleshooting, diagnostics, natural language of SQL. I showed a new experience for you as developers to start mirroring your data in SQL in the Fabric and unleash all sorts of different analytic experience as well. So let me go ahead and flip here to the end, and let me bring Asad Khan back out on stage. Asad, if you come out here for a second, we got a few minutes left. I'd like to interview you, Asad. Did you know I was going to interview you?
Yeah, no,
you didn't know that? I just saw the time in our job. Like, Asad, I got to interview because I got to find out what we're doing for the future. So we showed some pretty cool stuff today. In fact, one of the things I ended with, Asad, was the Fabric. So I'd like to know from your perspective, well, why is it important for SQL to be part of that story, and kind of where do you see us going?
No, thank you, Bob. So I think the first thing is that in order to have a roadmap where we consistently invest in key themes, we have to define enduring themes. And the 4 pillars that we showed you represents those themes that we are after. Now, as you talk about the Fabric, and one thing which you will notice is that we strongly believe that the industry is going in the direction of the converged data platform. And what I mean is that the friction which exists today and goes all the way back to on-prem SQL when people would use external tools or SSIS, gone are those days. We need to remove the friction where the data can easily flow. But when the data easily flows, it should not impact the security constraints, the encryptions that you have done, the masking of the columns that you have done. All of that has to be taken care. Which means it's not just about like I took the data, backed it up, and then loaded it somewhere. And that is where we believe that Fabric can play a big, big role. It already has all the key engines for your analytics. SQL is already integrated into that. In the coming months and years, you will see how we are going even a step further on that one. But this converged data platform is a thing, and we are a big believer in that strategy.
And we're seeing good adoption from all sorts of people, right?
Adoption. Like you can, today you can, if you are in SQL, in Azure SQL, you can go to any database and you can say, I want my data to be available in Fabric, and all of that data will be available in Parquet, which means you can use any engine of your choice to go and do analytics on top of that. You can go and do joins. As Bob showed, you can bring data from Cosmos and SQL and then merge it and then do analytics on top of that. You can train machine learning models on the data, which is now on SQL.
There's even unstructured data. You can even bring like shortcuts from any data source or anything you want to put all that together.
Yep,
right? Okay.
Absolutely.
Now let's talk about AI. We'll also spend a lot of time talking about that. It's a big story for us, right? Now we showed Azure SQL database, but in my mind here, like I've got a big audience, right? Like, would you think that AI for SQL is just a bet for us? Like we need to be doing this, right?
We have to be doing it. And again, over there is the table stakes, which we believe that the SQL has to do. And then there are differentiators. And we want to make sure that we not only do the table stakes, but we also differentiate ourselves. And over here, like again, our opinion is that database is where all the high value data is sitting, and we need to push more and more AI capabilities into the database themselves.
Awesome, awesome, great. So co-pilots, I mean, yeah, that's my passion. I talk about co-pilots all the time. I mean, do you believe that that's an area that we should continue to invest for developers, like GitHub Copilot? You think that's an area we should?
No, absolutely. And I love the way you were describing and how everybody has a co-pilot. But again, imagine that you go to ChatGPT or something and ask a question about the SQL language or something, versus you are sitting in the IDE of your choice and you are connected to your instance, and then you ask that question. There is a huge difference between the two, because we know the telemetry data, we know your schema, we know all of that, and we can ensure that no data is leaving the boundary of your enterprise. So that is where the power of the specialized Copilot come, and we want to make sure that we deeply integrate in the experiences where you spend your most time.
Awesome, great. Like that context-sensitive experience, right? So drivers, we got a big dev audience sitting here. They're all different programming languages. They hit Asad. I think people are skeptical that we're investing in this space, but what is your opinion here?
No, I think like one of the regrets, honestly, I have is that we did not invest enough in all the languages, like obviously the .NET and C# and those from the early days we have been investing, but not in all languages. And this is something that is the reason we wrote it as it might look misfit as compared to the other broader topics. But we wanted to tell that as a SQL team, as a product team, we are super committed, and we are investing a lot on this one. We are looking for feedback. And please let us know if there is anything which we need to do more.
Our team's here that works on this space, so please reach out to us. We want to talk to you. So final topic, hyperscale. I'm part of the problem here. Years ago, I was talking about hyperscale as hyper and scale, 100 terabyte. But how do you envision that as part of our default scenario?
And I think like one thing which people might not have noticed is that today, if you go to the SQL DB and pick a prod database, the default is hyperscale. So slowly we have been moving into the place where the simplicity of SKUs is something which is important for SQL, because obviously SQL has, as I said, like a long history. It was one of the first PaaS service in 2012, which even GA'd on Azure. So obviously a lot of SKUs were built over time, but we want to bring the simplicity for our developers, where there is one architecture, there is one SKU that you can go and use it with confidence and gives you the full power of SQL. And that is where the hyperscale is.
I don't think people realize the price reduction. So was it your intention? I think the price reduction is a way, and we don't talk about prices in these events, but it's important.
Yep.
This is like the cost of commercial open source now or something, right?
Yeah. So this is I don't know how many people notice that, but SQL pricing is, even in the clouds, was set based on how we sell SQL on-prem. Where there is the manageability cost, but there is an IP cost, and it used to be covered through licensing. But even when we moved into the cloud, the only difference is licensing per year changed into licensing per minute or even per second. Last year, we made the decision, which was, as you can expect, it's a tough one because SQL just drives so much revenue for Microsoft, is that we removed the licensing price. So at this point, if you are spinning up hyperscale, there is no licensing price. It is matched, and we matched it as Bob is saying. We picked one of the popular open source database, and we literally priced cent by cent. So that reduced the SQL pricing by almost 38 to 40%. But we believe this is the right thing to do, because we wanted to make sure that is not part of your decision making, which is like, yep, this is the best price, and now it is the same price, and now I need to go and pick the right and the best database. So this was a change. And again, as I said, like money is always tricky. Like we are not the one responsible for accounting, but we wanted to make sure that when we talk to the developers, when we talk to our customers, pricing is not the worry for them.
Awesome. So you get the deck here at this link at the bottom here. Muazma, again, thank you so much for being part of this. Asad, thank you for coming today. But anything you'd like to close us out with and a comment about this event or about your commitment to developers for SQL?
Yeah, no, I think like as I started my talk, that I want to thank all of you. Like I think SQL has been such a successful product for Microsoft because of the community it has. And the community is about the developers. We have the IT people, we have the DBAs we have, and also all the partner companies who have built a rich ecosystem over the years. Our commitment to you is that if you are betting on SQL, we will not let you be behind in terms of any innovation. We will make sure that any innovation that comes, whether it is in the AI space, in the co-pilot space, we are in front and center in investing. But at the same time, obviously, we are also looking for feedback. If there are areas where we are not investing enough or where we are not going in the direction you think the industry is, please give us feedback, and we would love to spend time and talk to you more.
Awesome. Thanks, Asad. Thanks you so much, everybody. Enjoy the rest of VS Live.
Thank you.